14.1 is graphing trig functions, and there are several examples of graphing individual trig functions. You can watch as many as you need to until you feel like you get the hang of it. This video is just kind of an intro so you understand how to graph them, because sometimes you get caught up in the motions that you don't really understand where the actual graph comes from. So I want you to think about a sine equation. You're familiar with y equals sine of x, and you're also familiar with, on your unit circle, all the following points over here should not be unfamiliar to you. So if I asked you to kind of unravel the unit circle, I'm going to pick some real easy points here, obviously. So remember that your sine is, you know, kind of like your y coordinate, so keeping that in mind. And I'm going to do down here, if you follow my table here, I'm going to do the sine of, I'll start with 0. So the sine of 0, of course, is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3/2 pi is -1. And the sine of 2 pi is 0. So again, I just took the y coordinates, you know, all the way around. Then I'm going to go in the negative direction also. So if I go this clockwise now instead. So sine of negative pi halves is -1, sine of negative pi is 0, sine of negative 3/2 pi is 1, and sine of negative 2 pi is 0. Now if I plot all these points on a coordinate plane, but notice it's scaled by pi, and this is scaled by 1s in case you can't read it. So the first point, I'll start with negative 2 pi, will be at 0, and then negative 1.5 pi is at 1, negative pi is at 0, negative pi halves is at -1, 0, 0 the origin, pi halves and 1, pi and 0, 3/2 pi and -1, and 2 pi 0. And you can see the sine wave, which I'm sure you've heard of anyway, the sine wave. And how cool is that? So now you kind of know where it comes from. Granted, I could graph every single point along here if I really wanted to, but obviously that's enough points to get an idea of the function. I'm going to do the same thing with the cosine graph, but I'm going to do it rather quickly now that you get the point. So cosine, remind yourself, is the x-coordinate all the way around the unit circle. So if I do cosine of 0, that's 1. Cosine of pi halves, cosine of pi, cosine of 3/2 pi, cosine of 2 pi, and then I'll go negative, so I'm going clockwise. Cosine of negative pi halves, cosine of negative pi, cosine of negative 3/2 pi, and cosine of negative 2 pi. And then I will graph all of these, starting with negative 2 pi, 1, negative 3/2 pi, negative pi, -1, negative 0, 1, pi halves 0, pi -1, 3/2 pi 0, and 2 pi 1. And you can see the cosine wave, which actually looks very much like the sine wave. In fact, I'll draw the sine wave here in a different color so you can just kind of get an idea. But the sine wave actually goes like this. So it just looks a little bit different, but they are definitely very similar. Again, just unraveling that unit circle so you know where it's coming from. So terminology you're going to want to be familiar with, and you can, these are straight out of your textbook, but you can certainly write them down, probably a good idea. So amplitude is, I'm going to just put in simplistic terms here, the height of your sine or cosine graph, The amplitude is half of the difference of the maximum minus the minimum. So if you have a cosine or sine wave, and let's say, you know, it goes like this, you're going to take the a maximum and a minimum, and then that difference you're going to cut in half, and that's amplitude. So basically you envision what's called the midline that cuts this thing symmetrically in half, and the distance from the midline to a max or from the midline to a min point is your amplitude. Periodic function is just what we graph, so it's a function whose graph has a repeating pattern, so obviously a sine wave and cosine waves go on forever. A cycle is the repeating pattern of a periodic function. The period and frequency you're going to want to familiarize yourself. You're really going to use amplitude, period, and frequency, by the way. So the period is the horizontal length of a cycle. So if you have, again, a cosine wave that looks something like this, the period is the length of a cycle. So a cycle is one start to end repeating pattern. So if I start here, then it goes down, and it comes back up, and then it's going to repeat itself. So from here to here would be the length of the cycle, hence called the period. And frequency is the reciprocal of the period. So if I know my period is 2 pi, frequency is 1 divided by 2 pi, so just the reciprocal of that. And that tells you the number of cycles per unit of time. So that means one cycle occurs in every 2 pi lengths of time, which is kind of a duh. Domain and range, and this is all without shifts, of course, which is our focus today, but the domain for all of these functions. So the domain is all real numbers, and you can see I just graphed a cycle here of the sine and cosine wave. So this one, the sine wave, you can see that the domain is all real numbers because it goes on forever and ever. I mean, that's one cycle, but it never stops. And same with cosine waves, never stops. So all real numbers, very simple. Take this thing and shift it wherever you want, and the domain's always going to be all real numbers. The range, however, is going to be based off your amplitude. So like on this one, you can see that the maximum is at 1 and the minimum is at -1. So my range is everything between -1 and 1. Note on the cosine wave, the same thing occurs, of course. You have from 1 through -1 from your maximum to your minimum. Now, if I take either of these waves and shift it up or down, then my range is going to change depending. So again, it all revolves around the amplitude, which is your maximum and minimum points, and your range is everything in between those. All right, we're going to go through a couple equations before we talk about really the nitty-gritty of graphing, but you're going to need to recognize amplitude and period. So first and foremost, here are the equations. Y equals a times sine of bx, and y equals a times cosine of bx. A, which is the number that you're multiplying the functions by, will give you your amplitude. And it doesn't matter if it's positive or negative. We'll get to that eventually. If it is negative, it's going to be just a reflection. So if I have a 2 or a -2 as an A value, it just means that the maximum and minimum points are going to be at 2 and -2. Then your period is 2 pi divided by the opposite value of b. So now the number in front of the x, whatever that is, you'll divide your period, which is typically 2 pi, by that. This is not frequency. B is not the frequency, so if you wrote that down, it's not. Frequency is defined as the number of full cycles completed in 2 pi. But they are not, frequency is not B. So B is just B, doesn't have a special name. When you're graphing sine and cosine graphs, you're going to think of the graphs as kind of 4 sections, and I kind of highlighted that at the beginning of the video here. So let's just say you have a sine wave and the amplitude is 2 and the period is 2 pi. Okay, so I want you to envision, you know that your period is 2 pi, so from 0 through 2 pi is where one cycle will occur. So remember, one cycle occurs in the length of your period, and then the amplitude is 2, so that means like my maximum height will be 2 or my minimum will be -2. So one cycle, you actually can kind of see it in this rectangular region, I'll just kind of highlight this, will occur in that rectangular region. So then you know that, I mean, you could just think of any sine graph here, and I'll switch colors, but you know that the sine of 0 is 0, the sine of 1/2 pi is 1, but the amplitude is 2, so that's going to bring it up here. And then it's going to be on right at pi on at 0, and at 3/2 pi it's going to be down the length of your amplitude, and then back on 0 at 2 pi. And that's going to be one cycle of your sine wave. So again, kind of thinking about this as when you get your start and your end, then you find your midpoint, which would be at pi, and then you find the midpoint between these 2 points, which is here, and then the midpoint between these 2 points, which is here. So it's actually quite simple once you get the hang of it. Cosine, kind of the same thing. So your period is 2 pi. So from 0 through 2 pi will be one cycle. and your amplitude is 2. So it's kind of like between -2 and 2 in this rectangular region will be one cycle for your cosine wave. So again, cosine actually starts above, so it's going to start here, and then it's going to end here, because remember your cosine wave kind of does this. Halfway in between is pi, and that's going to be down here. Halfway in between 0 and pi is 1/2 pi, and that's going to be here. And halfway in between pi and 2 pi is 1.5 pi. And that's your one cosine cycle. So again, thinking about it kind of in 4 sections, so halvesine and then halvesine again. Alright, the last graph I'm going to talk about is the tangent graph. And it has the same type of equation, y equals a times the tangent of bx. I want you to, first before I talk about the tangent graph, think down here, think about where tangent is undefined, because sine and cosine aren't undefined anywhere. But the tangent is the y divided by the x, or otherwise known as sine divided by cosine. So that means cosine can't equal 0 because you can't divide by 0, right? So it's going to be undefined anytime the cosine value is equal to 0. So if you think about a unit circle, cosine is your x-coordinate, and it always equals 0 at pi over 2 or 3/2 pi. And of course any increment or coterminal angle that of those, you'll have an undefined tangent value. So thinking about cosine, you know, if I were to maybe graph this, and let's just say this is pi and 2 pi. So that means at pi over 2 and 3/2 pi, they'd be undefined, and that's what we call, or that's where asymptotes, of course, are going to be. Then if you think about pi, the sine of pi, of course, is, tangent of pi is 0. And then you might need some in-betweener points, and we'll talk about that eventually. But anyway, the graph is going to just basically do this. And you can see a tangent graph over here, too, which is much neater probably than what I just drew. But this one is a shifted tangent graph, so I just wanted you to kind of understand why we have all these vertical asymptotes, because tangent is actually undefined at certain values. So going back up here, the period, instead of 2 pi divided by b, is now going to be pi divided by b, and that's simply because tangent is interrupted by those vertical asymptotes, so where they are undefined. So the vertical asymptotes are odd multiples of pi divided by 2 times b. So basically, if you know your period is pi divided by b, your vertical asymptotes will be pi divided by 2 times b. And then your halfway points, you might want to write this down because this actually is not in your textbook, and it might be useful. And when you watch the graphs on tangent, this will make a lot more sense. But the halfway points are at pi divided by 4b, and negative pi divided by 4b, that's a 4. And then the y coordinates are a for the positive, and then negative a for the negative. So if you look down here, between pi halves and 3/2 pi, of course they're both undefined. So then and a is your amplitude, by the way. So I got my vertical asymptotes at pi halves and 3 pi halves. And then the halfway points are going to be halfway in between there and there. So basically if I went halfway in between pi and pi halves and halfway in between pi and 3/2 pi, then I would go down whatever my amplitude is and up whatever my amplitude is. And that's what these are showing. And then you really have enough to see that tangent piece.